Hello all. So in the last session we have seen what is data, how data is represented and types of data. So now in this session we will discuss about some statistics in the data. Okay, when I talk about statistics of the data, one thing that comes into our mind is central tendency. So we will see what is central tendency today. So in statistics, basically the central tendency represents the descriptive summary of the entire data. Okay, so central tendency is basically stated as the statistical measure that represents a single value of the entire distribution of a data set. Suppose I have 100 samples of a data and I want one point or one particular representation which will give me the entire analysis of the data. So we use central tendency for that. So there are three most important commonly used measure for central tendency, which are mean, median and mode, right? So let's see each one of them. Mean is nothing but the average of all the values in the data set. It is basically calculated by summing up all the values and then divide by total number of values. So here mean is calculated as summation of x by n, where x represents all the samples. If suppose I have 100 values, summation of x would be x1 plus x2 plus x3 so on till x100 divided by 100. Okay, x is each value in the data set and n is the total number of values. Okay, so when we talk about mean basically gives us the average, but there are some cases where we cannot use mean in machine learning. Okay, so all of us know what are outliers, right? So if suppose I have 100 values in the data set where one value is totally different when I compare it to the other 99 values, so that value which is totally different is called as outlier. Okay, let us see an example. Here I have the details of 10 staff along with their salary. Okay, so when I look into the salaries of all the staff, they are starting from 15k, different values 18, 16, 14, 15, 15, 12, 17, 90 and 95. So out of these 10 values, these last two values are considered to be outliers. Why? Because all these lies in the range from 12 to 18k, but whereas these two values are nowhere related to them, they are totally different. Okay, so these values are considered to be outliers. So how does this affect? When I take the average values of these 10 samples, the average value would be more than what is expected, because the average values of these employees would be around 15 to 16k, but adding this term to this, the average value would be greatly affected. So mean cannot be used in machine learning where the data is suspected to outliers. Okay, so it is the second central tendency measure is median. Okay, so the median is nothing but the middle value of the data set when the values are arranged in ascending or descending order. First, when you want to calculate the mean, you have to first arrange the data in ascending or descending order and then calculate the middle value. Now this median again differs depending on the number of values you have in the data set. If you have odd number of values, the middle value would be only one. But when we talk about even number of values, we will have two middle values. So we take the mean of the two middle values when we calculate the median. Okay. Now when I talk about mode is nothing but the value which appears more frequently in the data. As you can see here, I have values 1, 2, 3, 4, 5, out of which 5 is most frequently repeated. I have 1 only once, 2 twice, 3 once, 4 twice, whereas 5 is repeated thrice. So the mode is 5 here. The most frequent repeated value is called as mode. Okay. Now when we talk about data, the data distribution is also important. If you want to understand the statistics of data's distribution is also important. So we basically have two types of data distribution. One is called as symmetrical distribution, second one is called as skewed distribution. So symmetrical distribution is nothing but the normal distribution of the data, that is the data is divided equally onto the left and the right. But when I talk about skewed distribution, okay, so skewed distribution is when the scores pile or stack up on one side, whereas the other side would be totally skewed. Okay, so there are two types of skewed distributions, as you can see, positive skew and negative skew. Okay, now when you look at this is where the scores pile up on the lower end of the values. Okay, and then on the other end we have a tail like structure. So this is called as positive skew. We call it as positive because all the values are present on the left hand side. Okay, so since the tail is towards the higher end of the values, it is called as positive skew. It is skewed right because the tail is pointing to the right. When you look at this negative skew, the tail is pointing to the left. Okay, so this is generally called as negative skew. Okay, so this is where negative skew is where the scores pile up on the higher end of the values with tail representing on the lower end. Okay, this is called as negative skew. So normal distribution, skewed distribution. Okay, so mean, median and mode are also differed when you talk about the distribution of data. Let's see how the distribution of data affects mean, median and mode. As you can see, if suppose you have symmetrical distribution of the data is equally distributed, then mean, median and mode would be the same. Okay, but when you talk about skewed data, if you have negative skewed data, mean is less than, median less than mode. Okay, the values of mean less than, median less than, mode. When you talk about positive skewed data, mode would be less then median and then mean. Okay, this is very important for us to analyze. Okay, so based on the distribution of data, mean, median and mode would be affected. Okay, so summary, mean actually summarizes the data. Basically, when we talk about regression task and data pre-processing, we would be using mean. And then when I talk about classification task, as I told you in the beginning, all the machine learning algorithms are broadly classified into regression and classification task, right? So when you talk about regression, we'll be using mean. When we talk about classification task, we'll be using mode. Okay, so when we are handling skewed data for feature selection and all that, we would be using median. Okay, so when we talk about outliers in the data, we cannot use mean and we cannot also use mode. But when you have more number of outliers in the data, we usually use the median. Okay, so dealing with the outliers, we use median. When you're dealing with regression task, we use mean. When you're dealing with classification task, we use mode. Okay, now let's consider an example. Consider the following data set representing the salaries in thousands of a group of employees. Okay, so I have 30,000, 35,000, 40,000, 45,000, 50, 55, 60 and 200. Okay, so what is the outlier here? 200 is the outlier here. So okay, when you calculate the mean here, what is the formula for mean? Summation of all these salaries divided by n. So summation of all these salaries, and I have 8 samples. So the average salary is 64.375. Okay, so this is the mean. Okay, now when I talk about median, first we have to sort them in ascending order and then I'll calculate the median. Median is nothing but the middle values. Okay, so as we have even number, we have 45 plus 50 by 2, that is 47.5. So when I have calculated the mean, it is 64. When I have calculated the median, it is 47.5. Okay, so the mean is 64.375, which is significantly higher. Okay, when we look at the salaries are starting from 30 and the highest one excluding the outlier is 60, but here the mean itself is 64, which is higher than the usual, and this is because of the outlier which is present in the data. But when you look into median, the median shows the value is 47.5, which is typically okay because the values are starting from 30 and ending till 60. Okay, so median will give you the proper summary of the data when you have outliers. So just understand that when you have outliers in the data, don't use mean but use median. Okay, so mean, median and mode are basically fundamental tools in machine learning that will help us in understanding the data and how the data is distributed, such that the model will have better performance looking at the analysis of the data or statistics of the data, ensuring robust analysis. Okay, but we have to make sure that we select the appropriate measure based on the data that is available, based on the characteristics of data, to improve the accuracy and performance of the machine learning models.